Okay, so what are we doing? We're doing a scrap Harvard 400M. I've got a scrap chassis from another dealer. This is my scrap chassis Harvard 400M with a lot more missing than the one we've received. And what we're going to try and do is to get this to work. Now the fact it's already been scrapped, so far I've replaced the missing preset there, which would be the squelch preset. I've replaced the missing MC3357, and we're just about to put this resistor in, which is 5.6K, which I observed was missing from there. Okay, doesn't look like the hole's been cleared out. I'm not sure what all this extra wire is. It doesn't look very good, but it certainly isn't there like that on mine. So where were we? We're putting that in. It's about there. Better turn the power off. Gone and lost it again. Is it there? Yeah. This resistor's probably worth more than the radio. You don't see many of these sets, and so when I saw I'd got a scrap chassis, I thought, well, I don't think I've ever done a CB240 of any description since doing this channel. So they appear as either the AlBA CBM1 with the slider controls, which is the manual I'm working from, and they appear as the Eurosonic Euro 1 and Euro 2, not Euro 2 with Roman numerals number 2, which is the GT868 version, and the Harvard 400M, which of course is what we've got here. So at the moment, I've made a mic up. It's one of these unique pinouts. I've made a mic up, and it'll go in. It's lighting up. I'll show you in a moment, but it's not doing any transmitting or receiving. There's no hiss on receive. There's no noise into the speaker whatsoever. This had had a lot of soldering rework, not necessarily that well done, and I've done the isopropyl alcohol on it. So, is that a dry joint I just spotted? Probably worry about all that later. Certainly been messed with, hasn't it? And that's why it's been scrapped. Right, we'll power it back up again. So absolutely nothing from the speaker. If we put it into transmit, absolutely nothing. So I wonder if it's generating the channels. So I've got a handheld next to me. We're on channel 20. Let's go the right way. How do you get rid of the squelch? That way. We'll pick up the signal generator. No. So it's not transmitting, it's not receiving. So I'll just have another look. We'll pause the video, I'll just see if there's anything else before I start checking voltages. I'm not, how good's that? How good's that? What's that for? Because there isn't one of those in mine. Oh. Or should there be one in mine and it's missing? Yeah, there should be one, but it's missing. Quick voltage check. Probably the 8-volt regulator. Expect chassis 0 on these. So that's going to be input. Well, that's not good. It's all showing 12 volts. that's certainly not right. So we'll start looking at the circuit diagram. So power input BD125. So we should have, we've got a 9 volt Zener there. So I would be expecting 9 volts, and full rail voltage of 12. So that doesn't look right to me. But I wouldn't expect that to stop it working. I'd expect it to be over power. I'll have an investigation. Actually, I've discovered, as I keyed up and looked at the ammeter on the power supply, I put it in channel 9 in case there's a problem with the channel selector, and it does start to transmit. So I've now got it on manual on channel 15. 1 2 1 2. There's no audio, but there can be lots of reasons for that. So the synthesizer is now running on it, but it's the VCO's out of lock. So out of interest, I wonder if it's receiving. Of course, it's not hissing, so we don't know if it is receiving, do we? I suspect the audio IC is knackered, which is there. Seems to have had some corrosion underneath there. And I've got a spare IC on my scrap chassis. So that's something we could possibly do if I haven't got a new one in stock. So that is progress, because the fact it's not transmitting any power. I'll just check. No. No, definitely not. The chances are the output transistor is knackered, which is often the demise of these sets. It's an MPSU31 from Motorola. They're about 19 quid. I should have some in stock, because I spent a fortune with somebody in America for them. But I just wonder if we can set the VCO up. It might tell us whether the set's actually receiving. Phase lock loop alignment. So they want you to put a high impedance voltmeter to test point 1. So we can do that. Just need to know where test point 1 is. Test point 1. We've got, yes, it is actually a test point. That's nice. So they say connect to test point 1. And we're in channel 20. But that's so we can actually both see it. So what do we do? Well, they want you to connect a frequency counter and an oscilloscope to secondary of transformer 10. But I really can't be bothered to do that. So just transformer 7 until the voltmeter reads 2.8 volts in TX mode. And that's going to be, without going any further into looking it up, that is going to be the VCO coil T7, isn't it? So we need to put the thing into transmit. And as you can see, it's out of lock. the wrong tool. That's the wrong tool. That's the wrong tool. That's the right tool. Okay, well, I'm going to put it into channel 9 where we know it is locking, and we'll bring it down. Perhaps I'm on the wrong coil after all. Let's see if my laziness didn't pay off. What we're looking for, transformer 7. No, it was transformer 10. Must be the one that's not labelled. That's the one that's not labelled. So is it labelled on the other diagram? This is kind of from the bottom side, so yes, it is T7. Oh no, it is this way on. It is this way on. So that is transformer 7. So it's that one we should be twiddling and not that one. So let's try that again. I don't think I've ever done the VCO on one of these. Oh, annoying meter. So here we are, still on channel 9. Yes, so that does bring it down. So now we'll go to channel 20, and it is in lock, and it is transmitting from the VCO. So what was it, 2.8? Yeah, that's fine, you see. Just to transform the trimmer to 10.24. Well, we're not going to, because we'll do that later on. So that has set the VCO. So now it will transmit on channel 20. 16, 17, 18, 19, 20. There we go. Right, that's one hurdle overcome. The chances are it may well be receiving, but we can't hear it. And without a meter, we don't know. You know, normally you can see the meter deflect with it receiving, but we can't with this. I can put the signal generator on, but I don't think it's going to come through in any way whatsoever. There's the signal generator on full pelt. That's interesting. It's not coming up RX. We've got transmit, but we haven't actually got RX coming up. So we could have the 8 volt rail out or something like that for the receive. I mean, the relay could be dodgy, couldn't it? The LED could be dodgy. Oh, that's Roger Bleed. Oh, I bet it's doing that. Very quietly doing that. So we've got no receive, unless the LED stuff. If I've got a little amplifier on this bench, we could probe over the TDA 1905, but we haven't, and nothing's happening with the amplifier, so I think we will take that chip out and suspect that. So I think we'll probably do that tomorrow. So it's a good start anyway, and at least we've got the VCO locked and it's transmitting. We'll just test this. We'll just test this transistor. We're taking the output transistor out. I don't even know if it's in the right way around, do I? but I would think this is going to be faulty. Yeah, it is. There we go. So where did I stash my MPSU 3.1s? Well, that's anybody's guess, isn't it? So we'll come back to that tomorrow. And it's Sunday tomorrow, so we're inundated, of course, with church services. But I might find 40 minutes to have another go at this. Okay, so the next day. I've been looking forward to getting back on with this. So MPSU 31 output transistor there. So we know the emitter goes to ground. Because I'm not sure, of course, if the original was in the right way round. We have one in stock, so it was £19. I'm not expecting to ever order any more. This is the one and only one we're going to now replace. So this is working out an expensive set, but that doesn't matter. It's not a customer's, it's mine. There we go. So we'll get the tester again just to determine which really is the emitter. My guess is it's going to be this side here. Bound to be wrong. Gold plated and a gold plated price. You don't seem to see gold-plated semiconductors these days, do you? So, red is emitter. So I was wrong, wasn't I? So the writing where it says MPS is the emitter. So the emitter is going to be to the left. So we'll get this heatsink sorted out. Let's make sure we're getting all this the right way around. Yes. And which side is it fed in from? Let's put that in loosely. Yes, it's going to be from that side. Good. So we're going to have to make up an insulating kit because it isn't a standard one. So I think we'll use one of these heat pads. And then cut it accordingly. There's the trouble when things are missing. Now then, that's a new problem because that doesn't fit. So we're going to use nylon screw instead. And then we don't need to use the bushing. And then we have a new problem that we actually need a nut on the other end. See these people who put them on bad aerials, they don't care, don't worry about all the work and expense, do they? Perhaps we can get a insulator on this side. Yes, we can. As long as that doesn't hold it off, which it doesn't. So we should be able to get an ordinary nut. You never know, there may be something kicking around on the bench. Wouldn't be that lucky, would I? Right, I'll go in the other workshop and we'll just go looking for a suitable nut. Right, so I could have used a metal one, but I'd got a plastic one in the RS kit, so just check we haven't got continuity between tab and heatsink. So between heatsink and heatsink, just for a test, put it on a buzzer. And between tab, no. So that's what we're looking for, isolation. So I said MPS was the emitter, and that should now nicely go in there. Just play that out slightly. I wouldn't be surprised if we don't have transmit as soon as this is done. I don't think, looking at the current consumption and the fact we're transmitting a few inches, I don't think there's much wrong with the transmitter. We didn't have any audio, did we? Got a little bit from the Roger bleep. Not as easy now. And we have the nut and bolt. It's countersunk one. Oh, great. So the nut and bolt that goes through the printed circuit board is missing. We'll actually pinch it off this scrap set rather than starting to go and find more. How's this done? I've glued the nut on, all it looks like. I'd love to get this fixed today. The next thing's going to be this audio IC. Believe it or not, these are 5-watt audio amp if they run at 30 volts, and it's amazing that it can dissipate that kind of current. It uses pulse width modulation techniques, if I remember. It's quite a state-of-the-art thing at the time. Looks like it's super glued onto the back. Well, it isn't now, is it? I put it in, now I've tipped it upside down. Yeah, I'd love to be scratchy cornering this today. This is session 3. So you always do the mechanical things first before soldering, or you're going to end up putting mechanical strain on the soldered joint, and then you end up with the print coming away. So that's nice and solidly in there. Right, we'll solder that. Well, that won't be difficult with it being gold plated. We've got a bit of print missing there. Might do a Mr. Blobby. There we go, we've done a Mr. Blobby. Good. Now then, that looks a bit, where it's been unsoldered in the past, that didn't look too good. It's had a lot of work in this transmitter section, so I'm actually surprised we've got it as far as we have. That looks like a potential dry joint. There shouldn't be anything insurmountable on this, on transmit. Right, it's time to power it up. It's annoying that they're so close. Right, power supply on, 13.8 volts, and on we go. We have transmit. Do you see that small deflection? I just did it for a second. Excellent. So what's the tune-up procedure? Well, we've obviously got a trimmer capacitor there. It's doing about 1/10 of a watt at the moment. So there could be another fault, but it also could just be miles off tune. I'm tempted right now just to do this trimmer capacitor. So it is generating a lot of power. It's drawing over an amp, and it's not getting anywhere, is it? You know, doing 100 milliwatts. So its power's going somewhere, and this could be why the transistor's knackered. I suspect there's a component that's not right somewhere. So I'm going to try and do a very quick tune-up. I really don't want to burn out this very expensive transistor. Perhaps we ought to try it on doing low power. At least I'm still getting a deflection. So transformer 2, 4, 8 and 9 on VC1. So 2. Are we the wrong way on, or is this mirror image? Oh no, it was that way on. No, it's mirror image. It would be, wouldn't it? It's just annoying when it's like this. No, it bears no resemblance. Hey, it's that way on. That's it. Not mirror image, it's this way on. So 2, 4, 8, I can't believe that's right. Let's go back to circuit diagram. So here's the transmitter. We're going to be starting here. Well, certainly T2 and VC1. I have to go to full power. I can't read that. It just makes you wonder if there's a duff relay. No, that's not having any effect when you give it a bit of a bash. But it's developing, it must be developing 3 watts plus to be drawing the current it's drawing, but it's just not coming out of the aerial socket. So I think we just need to look for some dry joints for a start. I'll do that and then get back to the video. Okay, so behind the scenes, there's a capacitor missing from there which I've put in. I still haven't got transmit. I put it on low power. I've transmitted long enough for me to be able to set the frequency. So I'll just show you that I've done that. I'll just key it up again on low power so we hopefully don't burn out the thing. So 2779110 is near enough for now. So we've got receive. I pinched the audio IC from the other scrap set. We've got a terrible dry joint somewhere. We'll just see whether we can. I mean, there's nothing wrong with that sensitivity. It's 1 microvolt. So we'll just put the signal generator on and just run through some of this. Let's put S9 on. Oh, we're not on the instrument speaker. That's the extension speaker on the wall. There's the instrument speaker. So we'll switch over to the oscilloscope so you can see that. We'll do the detector wherever it is. It's going to be that one or that one, surely. So see with the manual in front of him. It's a very simplistic receiver. No, it doesn't. You've got no variable inductor in that area. So we'll just look at the others. On the synod meter, so it's exactly the same performance receiver as you're going to get with the Harvard handheld. I want camera 4. What is there actually on receive? Transformer 6. transformer 5, so there's just 2. See where those are. Obviously that one. 10, 5 and 6. Get this the right way around. It looks to be there and there's our 2 receive ones. You know what, they were absolutely spot on. So for 12 dB we've got 0.38 microvolts. I'm full of cheating if I get this whole thing working. So that's not so bad, is it? We're doing very well. So everything else will be to do with transmit. Well, you know, we're 7/8 of the way there, to be honest. I'm glad I've... So the second-hand MC3357 obviously works. The audio IC pinched off my chassis works. We have got transmit, it's just not coming out of the aerial socket. And we didn't have much deviation, but it may be linked with whatever else is wrong there. It doesn't look like I've got any squelch operation. Let's turn that right down. In fact, turn the signal generator off. Turn the squelch to full. Now that's the squelch preset that I changed. So I've got the squelch on full. Let's see whether we can actually get it to shut up. And the answer is no. There's going to be a component missing. So I'll carry on having a look. Okay, back into record, and we now have squelch. Let's see whether we can set it up. They're not a good squelch on these sets. This resistor was open circuit, 1K, pinched off the other set. In fact, it disintegrated. So, 100 microvolts on the signal generator. Let's put the attenuator on the inset picture, if we've got an inset picture. We have now. So 0.31. We'll turn it to full. It's coming in at 3, which is not good to me. But then they're not a good squelch. See what full does. Never comes in. Well, I'll tell you what, I think we may be getting somewhere. 30 microvolts. Tell you what, that's more use than I thought it was going to be. And the threshold. Straight in at 0.3. Actually 0.15. We'll fill in the form later. So I'm satisfied the receiver's working on this. So I daren't going to transmit to fault find the no transmitted audio, the low transmitted audio, until we've got to the bottom of why this isn't actually transmitting out of the aerial. So it's drawing the current, it's not getting the power. I'll just go back to that meter so you can see we're on a 3 watt scale, so that's 100 milliwatts, and if you look at the meter it's like 50 milliwatts. So need to get to the bottom of that or it will burn out the transistor, which is very expensive. So it could be that it's had this fault and that's why it was scrapped. It could have been reverse polarity, which is why we've got a wrong regulator transistor there. But although it's wrong, it's not wrong, if you get me. It's not the right part, but it's something which obviously does the right job. And strangely, it's missing on the other set. I had to rewire the speaker socket, and the actual speaker itself will no doubt wire across there and there. It's on the diagram, hopefully, so we'll come to that if we get that far. So looking at the circuit diagram, we need to be getting our diode probe so if we're getting output, which we are, there's either a short circuit capacitor along here which is shunting it to ground, but it's not, it can't be here because we do have some output. So if it was being shorted right from the output of the transistor, then we wouldn't get any output whatsoever. It's going to be further up here. It could still be a duff relay. So my thoughts are to get the diode probe out and probably look at the filter here. So L1, 2 and 3. See how they're laid out on this mirror image picture. Is it mirror image? No, it's not mirror image, Mr. 21. The trouble is it's not a good photocopy. I can't now see anything amiss because before we've got that capacitor missing up there. But usually with a relay, you'd find that no, it could be. Yeah, it could be. It did change. Can we take the lid off it? No. So the best thing to do is to get the diode probe out. So at the output, we'll work down. Let's try it there. Quite a lot there. So at the transistor, let's put that to full. Bearing in mind we're on low power. I think we'll probe the relay. Don't ask me which contact's which, but we'll soon find, won't we? if that's the input, well, the output's identical, so it's not the relay. Now we've got more there than we have at the output. It looks to me like that coil goes to there. We'll go through it and we'll get back to you. Right, well, the next day again, Mr. Chippie's actually come to the conclusion on this, and we've sorted this snag out. There's one of the things to tidy up, but it's now working as a radio. So, looking at the circuit diagram, it's a bit clearer actually from this photocopy or the scan from the instruction book, which has this information, than the service manual. So if we look here, capacitor 16 is 33 picofarad, and Mr. Chippie found that there was 22 nanofarads fitted there by mistake, and it looks, to be honest, he says it looks factory fitted. Now we don't know how they tune these up at the factory, but the set's drawing the current and he's doing enough power to drive the frequency counter. If you were working on current consumption rather than RF output, then you would pass the radio as working. So there you go. You don't know how they tune them up at the factory. So it could be a factory error, which is why the output transistor was short circuit or open circuit, because obviously the thing's developing, 3 watts, 4 watts, whatever, but only delivering 100 milliwatts to the aerial, and it's all getting lost in the filter here. So let's put a picture-in-picture on, and now we will key up. We're on channel 20, and we're on the 3 watt scale, and we've got 1.6 watts. How about that, guys and gals? So we can do a bit of a tune-up now. So I'm going to start by resetting this. I could do with an RS type What's It trimmer. That's 2 watts. So it's possible this hasn't worked from new. Whoa, it's gone over 3. You'll notice we've not filled a sheet out on this. I'll probably start that shortly. So that's 3.5. Just do these again. We'll do the earlier stages because that's might also help. So I'll have to go and fetch the service manual back, won't I? Because the other thing was, before I do that, let's just see if we've got deviation, because that's something else we hadn't got. I was very, very low. Wallow. One, two, 1, 2, 1, 2, 1, 2. Put the walkie-talkie on. Testing 1, 2. Put the Roger bleep on. Nothing. So, the deviation control is it would tell me if I went to fetch the service manual. I'll go and fetch the service manual instead of wasting time. Right, so back to finishing the transmitter off. 2, 4, 8 and 9 it says. So that was 2, we've done that. 4, 8 and 9. So that's now peak. It's 3.5 watts. It says in the service manual the limit spec is -2 dB. Can't be bothered to work it out, so it could be 4 watts -2 dB. So that's done that. VR1 is the meter, so that's that one. No matter how I put these wires, they short out. Seems to be a dirty preset. And so that's somewhere near. What else have we got? And you should be doing 3.8 watts, it says. Yeah, well, on this meter it's probably doing 3.9 on anybody else's. Then it goes on, you should be qualified to do it. Oh, I am, how handy. So, audio setup for dummy mic. VR2 is deviation. So we've done VR1. That's VR8. VR4. VR7, VR2. Let's get our oscillator out. Now I can hear that making a noise as we adjust it. So it makes me wonder if is the mic wired right? And the other thing is, why haven't we got the Roger bleed? It could be a totally different reason. Now I have a wire up underneath. So is it possible that the wire that's off goes to the Roger bleep switch? So I'm looking at the back of the Roger bleep switch. grey wire and a blue wire. See if we've got anything on our scrap set. Huh. You see there's a chopped off blue wire. So this hasn't got the orange wire, just to make things more interesting. Now the Roger Bleak was working on this, so what's changed? But nevertheless we've got no deviation. So let's have a look at the back of the mic socket. We should have audio going where? So pin 1 is ground, pin 4, no, pin 4 isn't the ground. 3 is possibly what we're looking for. Yeah, I think pin 3 is the audio. So it's always possible that I've wired the microphone wrongly and that our information isn't correct. So the next day, we're on Tuesday. Should have it done today. We've still got no transmitted audio. So what I've done is I blew up the bit of the circuit diagram which is the microphone preamp, especially when it's the right way around. I'll just make sure this is turned off. So the microphone goes in there. You've got 3 stages of amplification, and the deviation control is there, and the output is via resistor 12. So the quick kind of test is to put your finger on the deviation control. Nothing really happens. I put my finger on resistor 12, we get something, get a bit on the emitter there, whip the transistor out, test it, it's fine. Change the electrolytic capacitor there in case it's dragging the voltage down, which it might be. It wasn't that brilliant, I must say. Changed it. But what we've actually come to is that the feed resistor for this circuit has in fact died a death. So it's resistor what? It's been and gone getting hot and it's burnt out. Even better if I could get it out. What on earth is that? 4.7, it's 8 watt. Or is it a diode? No idea. The third component inside there is what? This is a diode, it's diode 25. Right, we'll test whether that's working. Aha! We have a diode that's open circuit. So I'm barking up the right tree there, and it's diode number 25. simply 1N4148. So that resistor that I've chomped the end of, let's just check what that is. It's resistor 31. And it feeds the LED either the transmit or the receive one. Just check it is something like 2K2. Yeah, fine. So we want 1N4148, so I'll go and get one from stock. Right, so with a 1N4148 in my paw, put that to one side. We'll test this one. They're usually 1/10 of an amp, these. Yeah. Good. Let's put the meter away. There's still one or two other things with this, like the channel 9 switch. Puts the radio on channel 9 but doesn't display it properly on the display. There's an orange wire which I don't know where it goes, so there's just some, with it being a scrap set, there's just one or two things, you know, clearly chopped off at some time and things like that. So which way round does it go? And it's that way round. Put that in there. So hopefully there's no short circuit on here and it won't pop on, switch on. Anything that looks dry jointish while I'm at it. Right, switch on time. Testing 1 2 1 2 1 2. Hey, we've got audio. Oh, we've got a Roger bleep back. So we'll try and roughly set the deviation. 1. Right, now we'll properly set the deviation with the meter behind. Too loud, that. A bit too wide, shall we say. Let's see what it sounds like on the handheld. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. Good. So we've got transmit, receive, audio, everything. So it's just some of these silly little things. They don't have to be fixed. But it'd be nice if it can be done in some kind of reasonable time. So we'll connect back up to the normal, if I can say the word, test set. So as part of the diagnosis, I changed the 100 microfarad capacitor. So that's us back to normal, and obviously it's fixed the Roger bleed. Well, I'll tell you what we can do, and that is put the microphone connector back together. It didn't need the wire across, it's done internally on the radio. It doesn't need a receive. So it's just transmit audio and earth. So make things easier and chop that one off. Make things easier, chop that one off. And the people in the future think that wire's off, won't they? But it isn't. So the wiring for the mic was correct when I set it up using that diagram that's available to download. Right, so when I press the channel 9 switch, we'll switch that off, what happens? We get something strange. So there's going to be a matrix of diodes to make it read channel 9. Now, is it... we've got a bar out, haven't we? Didn't notice that on the other. So is it a wire off? Is it that wire off? And the trouble is, my scrap set is like that with no front, so it's difficult to determine. That bundle went to the LEDs once. What is this set? Oh, this is another Harvard 400M. This one's serial number 2099. This is serial number 21, which is fantastic. Goes with my Tango 21. Much later. And there is a difference on the board in the transmitter, unfortunately, while we're trying to fault find. You've got this extra yellow wire on this set, which we haven't got on the one we're working on. So, orange wires. I may have to detach the front panel to see if I can see anything at all. I've had a good rummage on the shelf, and I found a Eurosonic Euro 1. So this is the one with the Roger bleep on all the time. So the difference is, instead of RF gain, you've got DX and local, but it does have a channel 9 switch, and it might be possible that it's got the orange wire. So I didn't even know we got this, so this is going to be a forthcoming attraction. So although it was on the shelf, it was under a Giessen KR200, is it? Another forthcoming attraction. Put the scrap chassis now to one side. We could have done with this earlier, it would have actually helped. Obviously not working. Just whip the top off this one. So, orange wire goes to there. And now we've got a wire clearly off the channel 9 switch. So that is going to be interesting. Right. What it displays for channel 9, for some bizarre reason, it's also displaying the units. We don't have a service manual for the Eurosonic, and there isn't one for the Harvard. So you kind of got to kind of do the best you can. And I think we've just done the best we can. It is working on channel 9, but it's not displaying it. I don't even know it's supposed to display it. Tell you what, let's power this other setup instead. This could be fun, couldn't it? It's massively thick wire, like 25 amp type stuff. It does display channel 9. Okay. Let's just have a check with our own one. Oh, ours has still got the channel 9 switch. Wow. So I'm harping on about something. Put that to one side. We'll do that as a forthcoming attraction in a few weeks. Right, well, and there we have the missing green wire in the wiring harness. Well, I'll go to the foot of our stairs, except we haven't got one. Now that probably won't sort out the matrix showing the wrong thing. Right, we'll reconnect this. Obviously this needs a power lead doing as well. But I can do that in between finishing this video and having the on the air test. Hey! Fixed. Right, I'm not now aware of any anomalies. Well, I can't believe that. I've got the information all along. That's why we try not to take too much off some of these sets. Right, so I think I've got to go and do some shopping for an old dear. We need to just revisit the phase lock loop. Because I messed with transformer 10, didn't I? Because of being a silly Billy. So you select channel 20. It's 2.8 volts. At test point 1. Helps you plug the mic in. It's 1.5. Transformer 7 for 2.8 volts. So we've got that. So that's now done. We might. I think I'll go and do this shopping job. I'll come back. We'll fill in a sheet so that we don't miss anything. But I'm very pleased that we've now got this actually working. Right, so I've done Mrs. Thingy's shopping, done a photo. So you can see we've got this on the usual black and white photo. So the test point for the VCO, there's the VCO test point, 2.8 volts on channel 20 transmit. Frequency, this is 10.24 going to the receiver. Now I'm not sure we're going to set this. I'm not sure how we're going to set this. What meter's going to show it best. We've done the receive, the 3 for the transmit. Then we've got the pre-driver and the driver. So RF meter, S meter, deviation, low power. There we go. So we'll fill in a sheet. One thing I know is the serial number 00021. No idea what the date is today. Let's put it down as the 23rd. Right. MPSU 31 1N4148 100 microfarads 25 volts 4.7k. There's another resistor somewhere. 330 picofarads down there. MC3357 and TDA 1905. Probably about 40 quid worth of parts. Okay, so we're going to run it through its paces now. So we're on channel 20. We're into the final bit. We've got a working set. So we want to make sure picture in pictures on it is. So we're in high power mode. It's 3.6 watts. Channel 40, 3.5 watts. Channel 1, 3.7 watts. Low power. Helps if I switch it to low power. Now I need to do better than that. Got a bit of a dirty control. Let's see whether we can sort that out with the spray, or whether we're going to have to replace the preset. Now we're going to have to replace the preset on that one. Which reminds me, $10K preset. So low power. It is 50k by the looks of that. I think my other diagram's better. Yeah, 50k. Cut the part. And go to the door. Okay, so that's a courier with a hard drive, 500 meg Seagate one from the 1990s for my DOS computer as a secondary hard drive to make backups a bit easier instead of using 16 floppy disks. See how we're catching up? So what was that? 670416 from Rapid Online. Right, we'll try again. Switch it back on. Making sure we're in channel 20. Oh, it's like that, is it? Even with a new one. Why would that be then? Well, best we can set's 100 milliwatts. Assuming there's a design flaw rather than... There's no parts missing there. Now, the later version's got an extra wire. And we think that's to do with the low power circuit. So you've got a wire runs from a pin there to somewhere around there. It's got some kind of feedback. So I think that's one of the improvements it did. Right, back to full power. £801 milliamp. VCO was 2.8 volts. TX channel 20. To make sure it's on frequencies, go to the frequency counter. 9114. It was miles off, you know. So 9127. Deviation, I've already done it. Just do a little check on this one. Wow, look, so there's 2 on there. We actually know it's 2.2 to 2.5 kilohertz. RF meter. Central red zone. Meter lamp, switches, pots, sockets, not available. No mic, no speaker. We're going to introduce a speaker to it. So let's just check the receive sensitivity. We did the receive, as you know. So for a 12 dB sound, we've got 0.41. For 10 dB cyanide, 0.32. For 20 dB cyanide, if it actually does it, 2.4. Tells us it's a noisy kind of radio, doesn't it? And hopefully we've set the squelch now. It's a tight squelch, wrong knob. Isn't kind of how I originally set it, so let's go through that. this is one of the problems with these sets, a wishy-washy squelch. Don't think we're going to get better than that. No, because you see at that position it's nothing. It never works. microvolts. So not as tight as I'd like it. And at the sensitive end, set threshold on the radio, 0.86. Right, S9 on the meter. That just needs aligning. That's there. Well, so we'll put the top lid. It's not as easy as that, is it? We've got to put some extra wiring in. We've got a green wire. When I bought this scrap chassis, I got a lid with it, but only one. But when Matey sent this scrap chassis, he only had one lid for it, which was the opposite one. There. Make sure it cuts out. It does. Yeah, good. So what scrap set can I nick some wire out of? A scrap audio line, how about that? What we got which is long enough. That grey one. That sounds alright. So I think before we screw these on, no, are they M2.5 or M3? Yeah, they're M2.5. So tell you what, just for now, because I have got them, we bought them in for that DNT base station I'm still working on. We're actually waiting for an M2.5 tap to come from Taiwan or somewhere to do the whole, because the lowest tap we've got is M3. So just put one in there. There we go. Short the power lead out for a good laugh. Take the test set off. Put put the aerial on instead. I'll put some new screws in that when we've just finished this little bit. So meter off an AM set, 1 nano Roger, 1 nano Roger, you'll be lucky. Well, that did an awful lot of nothing. They must all be having their lunch. Anyway, I'm going to leave it on while I do the same. So thanks for watching Harvard 400M Resurrection from Scrap Chassis. Bringing 2 sets out of a dustbin and putting one back together. So my scrap chassis is even scrapper now because we had that IC off it. It's already had other things like the relay and the phase lock loop chip. It's still a useful thing to have. And weren't we so lucky that that switch hadn't gone and that the wiring was still intact to it. So there we are. That's taken some doing. I mean, what's the parts cost been? £40-ish plus 5 45-minute sessions. So well beyond the value, but I hope you've enjoyed seeing that. And I'm looking forward to the on-the-air test with Mr. Chippie.